Okay. So you attend this now. The model is already there.
Yes, I'm working on it.
Okay.
It's 62 million. So can you hear me?
Okay. Yes, I can hear you. What did you
I
get?
said 62.
62 million.
Yeah.
Okay. Let's give it a try. Equals from the model, we can see that in this case, our x1 is what?
Our S1 is 2.5.
Yes, it's 2.5 million. S1 is 2.5 million. X2 is what?
4.
S2
4 6
equals 4. Yeah. So we are computing for y. Y is equals 15.2 times
2.5
2.5 plus 2.9 times
4.
4 plus 12.4. So that's right. So you got it.
Yes, sir.
Moses, I hope you are following.
Yes, but I'll be off and on. I'm just trying to catch up.
Okay. We just created our multivariate regression model, and that's the outputs of the analysis. Now by the time you get your outputs, you should be able to interpret it, right? That's what makes you a professional. So, like I said, to create a model, you just focus on this section where you have coefficients, right? The intercept is always this figure that does not have x attached to it. That's the intercept. Okay, that's where the trend line intersects the y-axis.
The line is broken, sir. Maybe it's network.
Okay. Is it better now? Can you hear me now?
I can hear you, sir.
Okay. So that's the intercept, right? Then the independent variables are usually listed below the
Yes,
intercept.
very clear.
Okay, so this is the first x, the first independent variable, that's the second one, right? So with this, we create the model, which is y is equals 15.2, 15 Oh, okay. Let me write it out. Let me write it here. So the model is actually something like this. Y is equals, just tell me if you know what I'm doing. X1 plus 2.9 X2 plus what?
Plus 12.4.
Plus 12. So that's the model, right? That's the model. So to solve this problem, we can as well put this here anyway. Sorry, that's exactly what I had already put there. This is it anyway. So this is the model, right? 15.2x1 plus 15.2.9x2 plus 12.4. So that's the regression model. So this question now, which says using the above model, using this model, compute the expected sales, or we could say forecast the sales if 2.5 million naira is spent on advert and 4 salespeople are engaged. Okay, look at the table that we used to create the model. You have advert sales reps, sales. So if you spend 0.3 million on adverts with one salesperson, you got sales of 23 million. So 0.3 again, one salesperson, 25 million, and so forth, so on, like that. Okay, so we are now trying to predict if you engage 2.5 million, if you engage 4 salespersons and 2.5 million, what sales do you expect the business to generate? Okay, so we just slot in the values there, 2.5 million here and the 4 salesperson here, and that gave us 62. Okay, now there's something else you should always look at, which is what I explained the R squared before, right? Okay, always consider R squared. I told you if R squared is like 70 and above, that's impressive. Okay, which means the model has integrity, it's usable. You can trust that the model would give reliable results. Okay, so beyond that, there's something else that you look at, which I have not explained to you before. You don't find that when you use your scatter plots. Okay, if you look here, you see this ANOVA something here. Significance F. Okay, this figure, when this figure is small like this, it's an indication that you can utilize that model. Okay, and see it's quite small. It's lower than 0, it's lower than 5%. If you look here too, the same thing, significance F. We'll talk more about, I think we mentioned something like that when we're talking about the test. You can see it's also very small. Okay. Now, what this is trying to indicate is that actually the value of Y depends on the values of X. Change in X affect change in Y. That's what that is saying. Are you following?
Yes, sir.
You want to look at it from the perspective of hypothesis or hypothesis testing. Then you consider this p-value, this value. Consider the value. So when it's low, then it shows that actually the value of x depends on the value, sorry, the value of y depends on the value of x. So a change in x affects the changes or brings about changes in y. So those are the things you look at. So I hope it's all clear.
Yes, sir.
Is it clear?
But I have a question.
Okay, your question.
Yeah, my question now is, if, for instance, you want to engage like six sales rep,
Yes.
can you still use the same model, or you have to calculate everything again before you get the values? Like, can you still use this 2.9 to multiply by 6 to get it? Or
Yes.
you just have to,
Yes. You can use this same model. Yes.
okay.
You can use this same model, but before you, but you see something about this kind of analysis, business analysis is you have to understand the kind of business scenario you are dealing with. Okay. Now, it's possible that as you continue to increase the sales, these values, these independent variables, as you're going to increase them, you may get to a point of saturation, a point beyond which extra values will not produce higher values of Y. I don't know if you get what I'm trying to say.
Yes.
Yeah, so it doesn't mean that as you keep increasing it, Y must continue to increase. There must be a climax at
That's it.
which you understand what I'm saying.
Yes.
At which, beyond which, you will no more get that type of result. But
Yes.
you know, so those doing the analysis have to have understanding of the nature of that business, and of course also the business environment. Because if you are now engaging too many salespeople within a small area, are you sure that there are actually enough customers there for those salespeople to deal with, sell to? So you may not be sure of that. So you have to be sure of that before you can extend the value so much.
Okay, sir.
Yeah. If in a situation where it's a situation where you are dealing with a large geographical area, for example, let's say Edo State, and this is a product that is generally needed. It's an essential product you are dealing with. Okay. It doesn't depend on whether you are in the urban area, rural area, or something. It's just generally needed. Now, if it's such a product, and you know that with these three salespersons, you have only covered a small fraction of your potential sales areas, then you can continue to increase the salesperson and continue to get the expected Y. Are you following? But
Yes, sir.
if that's not the case, if the market is already getting saturated, then you have to be careful about that. Otherwise, you could increase it to 10 and be surprised that your Y will begin to give unrealistic values. That's why some experts will say that regression analysis is better for interpolation rather than extrapolation. In other words, the the values that you use to create the model. Don't extend values beyond it too much. Otherwise, the output you get may not be reliable. Is it clear?
Yes, sir, it's clear.
Okay. Okay, so now something else let me give you another exercise. Let's call this exercise 2. It's exercise 1. So work on this. Hope the question is understood.
You
Are you
said
there?
yes, you said the management of the business
Yes,
has engaged for sales rep, yeah?
yes,
If the sales target for the period in question is 75 million naira,
yes,
compute the value of the AVAT expenses needed to realize the sales. So let
yes.
me try, sir.
Okay. All right. Yes, so let's look at the solution to this. In this case, y is known. $75. X2 is known, which is what? 4, isn't it? Is that not so?
Yes, sir.
S1 is what we are looking for. Okay. So all we need to do is make X1 the subject of the formula. We already know that this is the model. If so, we can as well say that 15x1 is equals what? Y minus minus 2.9 x2 minus 12 points. Therefore, x1 is what now? X1 is equals, okay, before x1, let's say 15x1 is equals, what's the value of y?
75.
Equals
75.
75 minus 2 times
11.6.
okay, that's what you've got here now.
2 times 9, 2.9 times 4 is 11.6. So
Okay, that's what you got. Okay, so x1 then will be equals what? Let's just do that straight away. Let's say x1 equals what? X1 would be equals, that would be 5 minus, what did you get just now? 2.9 times
11.6.
minus 11.6 minus 12.4. I think this is still high.
That was what I got, 51.
That was what you got.
Yes. 51 million that I said I got.
Okay. Okay. This is correct. But it's so high compared to
Is the advert, the cost for the advert is very high, so
it's too high.
I don't know.
No.
Yeah.
Let me see. Let me see. Let me see. Let me see.
I was another way
Wait,
I was
sorry,
looking at.
No, sorry. No. 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 Yeah, this divided by, we didn't divide by the 15 now. That's why. Divided by 15.
Yes, I divided by 15. It was very small, so
Yes. So you divide all this by 15. You understand?
yes, sir.
Yeah. That's what was missing there. Divided by 15. Yeah, that's more like it.
3.4. Okay, yeah.
Yeah, that's the answer. So it's 3.4 million.